それでは時間になりましたので、オープンパワーのトラックを始めさせていただきます。私このトラックの司会を務めさせていただきます平野と申します。よろしくお願いいたします。今日は、足元の悪い中、GTC ジャパン2015にお集まりいただきまして誠にありがとうございます。このトラックは、オープンパワーのご紹介ということで、まずはですね、NVIDIA の本社がありますサンタクララから参りましたジョン・アシュレイというですね、オープンパワーを推進する立場の人間の一人として、IBM デベロッパーリレーションシップマネージャーという立場で、仕事をさせていただいております。彼の方から、オープンパワーのオーバービューといいますかアップデートをまずはお話をさせていただきます。はい、ジョン、your turn.
Okay, thank you. Thank you all very much for being here. My name is John Ashley. As Rana-san has already told you, I'm a developer relationship manager. I manage our relationship with IBM software and also help support other companies that want to move to OpenPOWER plus GPUs. Obviously, there's a lot of non-GPU things in OpenPOWER too, and I'm going to update you on everything, including some of the things that aren't NVIDIA related. So what is OpenPOWER and the OpenPOWER Foundation? OpenPOWER is really intended to be a consortium, a group of companies that are coming together to innovate in the hardware space and the software space. Today, more and more, systems are beginning to all look alike. You all have to do things one way. And our ability as individual companies in various fields to innovate, to deliver new functionality and new features was being more and more constrained. And so this was a place for us to go actually begin providing customers with more choice and more variety about how they solve critical business problems. It was an opportunity for us to innovate in the way components interact and communicate. And it was a place where, as a group, we all the OpenPOWER Foundation members believe that as a group, we can innovate more and bring more unique value to customers than we could individually. And so when we started OpenPOWER, there were 5 companies that were the original founding members of the consortium. We had a chip partner, so we had IBM providing the power architecture and giving us access, as a group, giving us access to a high-performance, data-centric compute platform, right? It has a heritage of being about data movement, data management, high I/O bandwidth. So it's a great platform to innovate in this data-centric age. And we had 5 companies, and that was at the end of December of 2013. Today, there's a few more members. A lot of people have found that the opportunity to do creative and innovative things is something they want to be able to do. It helps them unlock value they want to give their customers. And so as of last count, I believe there's over 145 members. That number goes up. There are always people in negotiations joining, deciding. And that includes now multiple partners at the chip level. So IBM has licensed the power chip design. There are other companies that will make power chips. There are other companies besides IBM that are going to make servers. There are other accelerators besides NVIDIA available in the OpenPOWER Foundation. There are software partners. There are end user research and lab partners, all of whom are part of the consortium because they want to help steer where that innovation is going, or they want to bring new models of computing. And we'll hear about one of those later in the sessions, actually. New ways to think about how we do compute and how we deliver that value. So I'm not going to talk to some of these slides, but they'll be in the pack so you can read them later. Otherwise, there won't be time, but a lot of things going on. It's been a fantastic journey getting here. And I want to talk about where we're going next. So, right, there is a sort of foundational plan. A couple of the members of OpenPOWER, us, IBM, Mellanox, have some committed deliveries to customers over the next several years. One of them we'll talk about a little later is the Coral project. There's some big data projects in the UK space. But we have committed deliveries based on this roadmap, which is useful for all the other partners because they know that this stuff's going to happen. They know that there are things they can start to build around. And so that includes faster networking. It includes faster interconnects between the GPU and the CPU. It includes more powerful CPUs. All of this is committed roadmap. All of this is being delivered to customers on these sort of timelines. And the other, I think the other piece is today, right, we're using a lot of the same technologies that everyone else has to use, right? That innovation engine is starting, but it hasn't delivered as much as it's going to. But from here, you can see where we're going. You can see the kinds of things we're going to do. I'm not going to, again, talk to a lot of these details, but there are a lot of really unique and interesting systems being built that one of these may be perfect for the problem you're trying to solve. Or looking at one of these, you may go, hey, wait, I have a better way to do that. And within OpenPOWER, you have that kind of freedom. There's not one vendor saying everything is going to be integrated this one way, and if that doesn't work for you, that's not, that's too bad. We're going to do it this way. That's the size that fits all, and that's not happening in OpenPOWER. I'm going to skip through a fair number of these things. There are many ways to get involved with OpenPOWER. If you are interested, please reach out to me afterwards or reach out to Hirano-san or some of your contacts at IBM or any other member. I'm going to talk very briefly about solutions. One of the things I mentioned is the Power chip today is its strengths are in memory, data management, I/O management. It's always had that heritage. And so if we look at codes today and the performance of things today, we see that on codes that are numerically intensive, that do a lot of math, we have rough performance parity with higher-end x86-based systems. If we move to codes that are more data-dependent, that move more data, that require more bandwidth, we see that the power systems have an advantage today. And if you look at the innovation that people are delivering in OpenPOWER, a lot of it is around data management, data movement, because that's where the big problems are in the future. There are currently something like 1,600 vendors and organizations, either who have software ported to OpenPOWER or who are porting to OpenPOWER. OpenPOWER is a little endian Linux, and I apologize to the translators for not having mentioned that when I was talking earlier. But it's a little endian Linux. It can read all the data files that everyone is producing today, and it's very easy for Linux vendors to port to it. And so there are several flavors of Linux already available. There are many packages. Most of the standard tools that you're used to just work. Right out of the box, they just work. And if they're data dependent, they work really well. There are some third-party examples. Very few of the third parties have gone public yet. GPUDB is one of the few that has. And again, these slides should be available as PDFs after the conference. There's innovation outside of the GPU space as well. Some of the FPGA partners are taking advantage of an IBM technology called CAPI and doing some really amazing stuff with memory management and being able to interact more naturally with memory. I mentioned briefly before the some U.S. government contracts to deliver on that roadmap. This is the Coral projects. It's systems for 2 of the major U.S. Department of Energy labs. And they're taking delivery of Power 9 and Volta-based systems in late 2017. So that roadmap is getting built, and it has customers. And as customers who probably aren't at those facilities right now, you get to take advantage of all that development money and all that interest and software work that's happening to support those labs. That's all just going to be there for you. So it's a great jump start for the ecosystem. I mentioned that data is something that a lot of the OpenPOWER solutions are focusing on. And a recognition of the value of this consortium, these technologies around data, is from the UK government, who with IBM is funding a major initiative to explore new ways to manage and process and analyze truly incredible amounts of data. There's a lot of work going on in the cloud. Lots of people are moving compute to the cloud. IBM has been a leader in cloud. Power runs the vast majority of the cloud software you would want to run. So there are people setting up clouds now. And there's a variety of critical workloads that now run Linux on Power, right? Because once Linux moved over, it brought a full ecosystem with it. And there are very few things that don't just work. And these solution stacks are continuing to grow. We're continuing to get more hardware vendors, chip vendors, board vendors, system vendors, and software vendors. And then on top of that, we're getting customer organizations, research labs that are helping all of the rest of the ecosystem figure out what are the most important problems to tackle. Because as vendors especially, sometimes we focus on the problems we see today. And those labs, those universities are busy thinking about the problems for tomorrow. And so they're bringing that into that innovation engine. And so they're a critical part of our partnership as well. So actually got through this much more quickly than I had planned. So there is plenty of time for questions. If there are any, I can go back and cover anything if there's something people wanted more detail about. So I'll open the floor up for questions. Oops. No questions. I told you everything you needed to know. Fantastic. Yes.
What do you see as the biggest challenge to uptake of power?
So the question was, what do I see as the biggest challenge to uptake of OpenPOWER? I think it depends on the customer, right? Obviously, having a broad variety of systems and system providers is, we're still getting to the point where everyone's got stuff in production, right? So where things are available commercially. And a lot of companies can't buy something they can't get from multiple vendors. And so there's some challenges there that we're pretty quickly, companies like Tyan and others are announcing systems, are shipping systems, you can order them. We're getting over those hurdles. On the software side, people just want to know, hey, does all the software I need work? And does it work well? And that we're getting through that process. I actually have a talk about that later. And I think there's a price performance question as well. Today, right, as I said, that innovation engine has gotten started, but it hasn't had a lot of cycles of innovation in it yet. And what that means is that performance on mini workloads is better than it is on current sort of more traditional systems, but it's not as much better as it's going to be. And so people are waiting to spend their money, or they're waiting to adopt until they see a few other people adopt and get some success stories. So it's early days, but I think the signs are hopeful, right? There's big customer commitments. The consortium has grown a lot, and there's a lot of customer representation in there, which is helping make sure that we stay focused on delivering things people want rather than things we want to make. I don't know, did that answer the question, or did I kind of dodge it? Okay, what answer were you looking for?
I think that's great. Were you going to talk about compiler technology later on?
I wasn't. There's another talk that will talk some about it. I wasn't going to talk specifically about compilers. The question was if I was going to talk about compiler technology. You have GCC, all the sort of normal Linux tools, all the sort of Linux productivity languages. You have the XL compilers from IBM. We've announced that we will have the PGI compilers available on Power. There's a variety of third parties and universities that are bringing compiler technologies that may exist already for ARM and or x86 and bringing them to Power. So it's sort of the Linux tools you expect are already there, and that includes some of the more esoteric things, even out to things like Go and so forth, and obviously all the basic standbys, C, Fortran, etc. But I hadn't been planning on diving in much more deeply than that into compilers, in part because I'm not a compiler expert.